Hello student, welcome again to the third lecture of your high voltage engineering where we have in part 2 we are continuing toward the Townsend second ionization coefficient. In previous lecture we will deal with one of the coefficient current equation where we see how in particularly ionization collision method current will be increased. In this particular logarithmic method, as you see in the graph, where the variation of current gap will be increases with applied voltage, and its graph you will see as the distance will be increases between the cathode and anode, the current will be linearly increase, and after the particular point it will be exponentially increased by E by P method, where E is the applied voltage and P is the pressure on it. Now, in next we will talking about the Townsend second ionization method. First ionization method is alpha. We will talking about in first current method. In second method, Townsend earlier in investigation observed that the current in the parallel plate gaps increase more rapidly with increase in voltage. Okay, as compared to one given by the above equation. Now, in this explanation, he will suggest that this departure from linearity carried out by the second mechanism. Okay, that is postulate that there is an additional current must be due to the presence of positive ions. Okay, there should be current, electrons are being more electrons will provided from the cathode side, but some more electron are being ejected. There is no derivative or there is no idea in the first ionization coefficient. Now he will again investigate, he will suggest that positive ion occur this particular increment or exponential rise in particular this current waveform. It will suggest that this positive ion will liberate the electron by collision with gas molecules and the bombardment against the cathode. Similarly, he suggests that photons will also release the electron from the collision. It means some more electrons are being released this particular collision method. So let us consider a phenomenon of self-sustained discharge where electrons are released from cathode by positive ionization method only. He will suggest that let us assume there is a n0 number of electrons are being released due to the ultraviolet radiations, and n plus electrons are being released due to the cathode due to the positive ion bombardment. Two type of bombardment are being there. First due to the UV rays, and second due to the positive ion that will meet from cathode ion tube. So due to this n0 and n plus, there is a number of electron that will be reaching at the anode will be addition of both due to the UV rays and due to the cathode, and this particular give the changeable equation of our as a previous. So number of electron is addition of both and exponential rise of E upon alpha d. It is called Townsend's second ionization coefficient that will related by V. It is a number of electron released from the cathode per incident item. So we will suggest that in this the number of electron released from gas, what are these? It is n minus n0 plus n1. The total number of electron that will release from gas is only small, that is given by n minus n0 plus n plus items. Okay, corresponding to this we will suggest that the V, that is our second ionization coefficient per factor. Now then this particular V, that is our second ionization coefficient, when we related with how many of electrons are being gathered due to the our UV light radiation, it will given by n plus by this our second equation, that is n plus Vn Vn0 plus Vn plus. It will suggest that n plus, that is in previous we will suggest that n plus the number of electron to the positive ion bombardment, having the equation of V of n minus 0 upon V 1 plus V, but V is what is V? V is our Townsend second ionization coefficient method. Now in this particular correlation where we wanted to know how much particular electrons are being created to the positive ion. Now you have to see a expression very denoted after this all the solution, or by the simplifying this we will suggest that the n is our number of electron given by n0 is initial electron from the your cathode side equal alpha d upon 1 minus v alpha minus 1 d carried in term of current. We will put the number of electron in term of current because electron are being equivalent to the flow of current. So it gathered by the one of the famous equations, that is I is equal to I naught E alpha AD. You see, I naught alpha AD is our first current growth equation. Okay, this whole I0 I naught by alpha D, it is our first current growth method. Just we have to be divide this 1 minus E alpha AD as R in our second ionization coefficient method. Okay, that is the earlier Townsend expression can be gathered whole throughout it. We can express as I equal to I0 alpha minus beta D. Okay, like this, where beta is the number of ionization pair by the positive ion. Townsend in this originally suggests that the positive ion that will be after collisions of the gas molecules release have some not good hold upon the ions, and they are be released loosely in the elastic collision, and ordinarily they are be unable to gain sufficient energy from electrical field to cause ionization with gaseous molecule. Is also be suggested by Townsend. All this both as we conclude both first ionization coefficient and second ionization coefficient, it will deliberately have R one of the most famous equation of Townsend, that is I equal to I naught E minus alpha D 1 minus V upon E minus A minus D. That is our give for the breakdown how much current should be increases during the breakdown of a gaseous medium. Just example, just sort out as a practical medium ki if there is a practical apparatus of a electrical apparatus having working on 30,000 volt, having some gaseous insulation medium of gaseous insulation medium. If we apply the voltage, increment the voltage one by one, the how much electrons can be getting from one side to another. Okay, including the variation of UV rays, variation of positive ion, it will conclude that the electron, we will suggest that current should not be there in this particular ionization mediums. We will wanted the particularly a breakdown, or we wanted a particular criteria how much current should be flown between these two particular plates. So it will suggest a particular criteria. It criteria suggests that ki if alpha AD is greater than 1, then current in the anode is equal to current in external circuit. What if only this possible? If only this possible, then current in outer side is equal to the inner side of the circle, if alpha AD is greater than 1 only. Okay, this theoretically proven that the current become infinitely large under the above mentioned condition. Practically it is limited by resistance of external circuit also. It given a critical condition that is called Townsend criteria. It will suggest that when V equal to alpha AD, or particularly denominator is equal to 1, there is a condition called, it is a beginning of spark. If the particularly condition when E alpha AD is equal to 1, then it will suggest that particularly gaseous medium will be break down and will act as a short circuited. So we have to be contaminated such type of things, where the number of ions produced in the gap by the passage of arc electron is avalanche is sufficiently large and resulting in positive ion bombarding. Okay, there is a self-sustaining method. It's called threshold sparking condition also. Second condition, as I suggest, alpha AD is greater than 1, then the produced by successive avalanche in cumulative. It means very large of growth of the spark should be there, and spark discharge grow very rapidly. If A alpha AD is very slow, then there should be no sparking between them and there is no insulation breakdown. That should be called upon. And that's it, where we thought about what should be the Townsend criteria and talking about Townsend's first and second coefficient method, where we suggest that what is the value of criteria. If we put on some of the gaseous medium, then at particular what value of current value, the particularly insulation will be breakdown. It will given by Townsend breakdown method. Thank you all of you for today's lecture. We will continue this lecture by how much insulation failures and other condition also. Thank you so much.